We're going to talk about parallel and perpendicular lines, and as you know, parallel lines never touch. So when speaking of lines on a coordinate plane, which we're looking at now, they're going to have the same gradients. They're never going to touch. If their gradients were different, eventually they would touch. So if the gradient is 5, I'll make this 5x plus 0. Then you can see it's plus 0. If there's no y-intercept, it means it's 0. As you can see, these are never going to cross, okay? So all parallel lines have the same gradients. Now we're going to look at this problem. We have to find an equation of a line that passes through 5, negative 10, and is parallel to a line that has an equation of y is equal to 3x minus 8. So our new line passes through 5, negative 10, and is parallel to a line that has the gradient of 3. Now I just mentioned that the gradients of parallel lines are always the same, and that's going to be the case this time as well. So the gradient of this original line is y is equal to mx plus c is 3. So we're going to use the same gradient from this line. We're almost there. We have part of our equation written, but we have to find where this line crosses the y-axis. But we know that it passes through 5, negative 10. So we're going to use that information to determine what our y-intercept is. Remember, these ordered pairs go x, y. Darn it. I don't know what's happening. Color-coded to make it a little bit easier to see. But now we're going to do a little bit of algebra to figure out where our y-intercept is. And we find out that our c value is negative 25. So c is negative 25. And now we can rewrite our equation with our new y-intercept and our gradients. Solution is y equals 3x minus 25.